So this is part 4 of my little series on how I'm adding a stepper motor to drive the lead screw on this lathe. In this video I'll just be looking at how I package up the electronics, how I did the permanent connection of the motor and putting it on a bracket that lets it be permanently connected to the lathe. And then at the end I'll give a demonstration of what that allows you to do by having a motorized lead screw and showing you cutting some work and how it can give you a better finish. So without further ado, let's get going. I needed to work out what sort of case I needed for the electronics. I had this old case, you can still get it on Amazon, just a plastic case. Originally I thought I'd put the controller, drive controller and the motor and the bracket all as one unit, but decided to break it up, so I changed from using the brackets that I'd 3D printed and attached to the motor driver. So I took those off, and the case is big enough that I can put the driver and the PCB with the microcontroller on it all on one board, all in one case but side by side. So I made this little aluminium bracket, just folded it to be the same size as the width of the plastic case, put some holes in it so they line up with the screw holes in the driver. And that worked pretty well for fitting it in the case. Tried to get it as exact fit as I could. I'll put some screws in from the side to hold it in place, but it's not going to move around much anyway. So you can see the PCB sits next to it. I need to rearrange the wires a little bit. So I put some spacers in to hold the PCB off the plastic. So just, you can see the 4 spacers there. And it goes in like this, and I can hold it up against those spaces, just putting screws in. I also changed around the power a little bit, so I split the power for the buck converter and for the motor now at that plastic connector on the right hand side. So it looks a bit nicer and works a bit nicer than trying to split it at the actual micro step driver. So that's it. So now I need to work out how and where I'm going to mount these OLED and rotary encoder. So to work out the position, I put a bit of masking tape on the front panel just so I could draw on it. Worked out approximately where these will go. I wanted to put them down the bottom of the case so it's closer to me when I'm running the lathe. I don't have to reach as far. So I just put some approximate positions where these two things are going to be. So the main thing I wanted them to do is to line up with each other. So I drew a center line. So that's kind of where the center of those two components will be. So I drew up the width of the OLED. So this is going to be a bit like the Bayes calculator, where I've got to drill a square hole or rectangular hole for the OLED to show through. So I ended up buying one of these tables. They didn't get great reviews on Amazon, but I think that'll allow me to, at least in plastic, be able to drill or mill out the side to the rectangular hole. So I got those milling bits as well, and here you see it's running. I'm just using my drill press, and I can wind the handles on the table to have the milling bit go in a straight line. This turned out to be kind of the limit of the rigidity of it, and even this wasn't that great. But it did work well enough that I could get a kind of rectangular hole with no bits hanging out. And see here, it doesn't look that rectangular, it's straighter than it looks. There's some masking tape and things hanging over the edges. Under magnifier you can kind of see the weird sides as well. Again, it's not that bad, the masking tape makes it look worse than it is. I did have to clean it up with a file. The other thing I did was to mount the OLED on the face, I ended up using the little mounting bracket I'd made for the Bayes calculator. So you can find the 3D print there, so that just allowed me to glue the bracket to the front of the panel and then screw the OLED in. So you can see here what the rectangular hole looked like in the end. It wasn't too bad. And I also put the button for the setting the display, so it displays either revs per minute, revs per second, or inches per minute. And also added holes in the side for the power supply. Used one of these aviator connectors for connecting to the motor. I just needed 4 wires, and that's what they provide. So you can screw that on. So this allows the case to be kind of separate from the motor when I'm putting it on the lathe. And I use one of these wall warts. It's 2 amp 24 volt wall wart for the power. So it all seems to still work. Kind of we saw in part 3 how all this works anyway, so I've done the proof of concept there, so this was just checking that it, after I'd mounted everything, is still working properly. It looks good. Here's the bracket. I need to put a couple of holes in here, cut it off there and there, fit better. So that's what it looks like. So I need to cut there and there. It wasn't too hard to cut through, just with a cutting attachment on the angle grinder. There we go. So that fits on the end of the lathe. This was the only nervous bit. I had to drill some holes in the end of the lathe. The lathe bed's made out of cast iron, so drilling is fairly easy, and then I had to use a tap. I'm using a 4mm tap here to tap out the holes for a 4mm bolt. So that wasn't too hard to do in the end. I was pretty nervous about this, drilling things in the bottom of my lathe, but that worked okay for mounting this plate. Then I just had to do the same thing for the second hole, so I made sure everything was aligning correctly, then center punched where the second hole will go, and did the same thing, tapped that out and put a bolt through it. So now with the case and the motor, it's fairly easy to attach it to the lathe when I need it. I can do it in a couple of minutes. I'll probably leave the motor on the lathe most of the time, and just only need to attach the controller and the power when I'm actually doing some work turning where I'm actually using the lead screw and want to use the motor, but otherwise I can move it out of the way. The other thing I need to do is make a case for the motor. At the moment it's just sort of hanging out there, so I think I'll just 3D print that. I didn't do that in this video. But that's next on the list, is just measure that up and work out some sort of 3D case to wrap around the motor there, just so that keeps it kind of clean and out of the way. You can see here where I'm testing it out, making sure the carriage is moving when I engage it, so everything's looking good. So finally, just show you an example of doing some turning with the motor controller. So I line everything up, gave it about 20,000th of an inch depth. I started this at about I think about 250 RPM on the lathe. I sped it up later. With the scared motor, seems to be plenty of torque to force the bit through the metal. I've had a problem with it sticking. This is where I'm turning some aluminium. I also tried some stainless steel, the only other hard metal I had. Has a struggle with stainless steel to get a good finish, but it can still push it through it. I wouldn't do it at this depth, but for aluminium soft metals it seems to be going well, and that's kind of what I'm going to be using this lathe for anyway. I don't think I'm going to do much. Definitely won't be doing stainless steel, but I have to see how it works with steel. I don't have a steel rod to practice with. You can see at 20,000, so going pretty smoothly. Gives a pretty good finish to the work. So let's have a look at that. Okay, I'm pretty satisfied with that. The finish isn't bad, just for the first rough cut, and the motor seems to drive it along smoothly, so that probably makes it a little bit better.